What we're going to be doing is we're going to be taking linear systems, and instead of graphing them and finding the point, we actually will solve it algebraically, meaning we actually solve for a value, okay? We have two ways that we can do it. We have a substitution method and we have an elimination method. You may like one over the other. Usually students find one that they love more so than the other, okay? And if you're not given, hey, do it this way, you can do it any way you want. However, I guarantee you, you'll have one where it says you must show it this way or you must show it that way, so you do need to know both, okay? So basically what it is you have two systems or equations that you see here, two functions here, and we want to then find what the values would be that would work for both, okay? We'll have one of the three solutions. Either this can be 1 point, it will be all undefined, or it would be parallel and no solution. So you still have those three options, but you're going to do it what we call algebraically, like through math, okay? So we're going to start with the substitution method first. And basically what the substitution method is it's actually solving for one of the variables in one equation, and then substituting it in to the other equation to solve for the other variable, and then plugging that value in to find out what the other one is. In short, you're all like, what? Okay, so let's work through this. How does this work, okay? All right, so we have these two down here, all right? The very first item that we want to do is to solve one equation for one variable. So basically, we look at either one of these equations, and we say, which one seems like the easiest one that I could solve for? What you want to look for is a coefficient of 1 in one of them. Okay? Yeah, and the second one has that. If you don't have a coefficient of 1, then find the one that seems like you could divide through easily. So like if there's one where they're all evens, or one where they're all like a base of 3 or something, and you'll start seeing that, because that makes it easiest. Okay? Here, this has a y, it's a coefficient of 1, it makes it easy to solve for y. Okay? So we're just going to take this first equation here and we're going to solve for y. So all I do is make y on one side and everything else goes on the right side. Okay? So this would be negative 3x plus 3. Okay? So then what you're doing is you're substituting this expression right here where you see y of the second equation. Okay? So basically the reason why you can do that is as follows. If we're trying to find a solution where they both equal each other, right? We're either trying to find where it's the 1 point, then therefore we can say at 1 point they are equal. So I can use this value and actually plug it in for where I see y and solve for x, because that's where they'll equal each other, and that's okay. So I'm going to take this value here where y equals this, and I'm going to take it and substitute in for y. So I'm going to come here and I'm going to go 3x minus 2, and where I see y, I'm going to plug this in right here. So I'm going to take this value, the negative 3x plus 3, and I'm going to plug it in where I see y. Okay? So I'll do negative 3x plus 3, and that should equal negative 3. Okay? So all I did was take what, instead of it being y, and I just made it this right here. Okay? And I can do that because we're trying to find the point where they're equal. Okay? At this point I can solve for x. So I'll have 3x minus, okay, so I have negative 2 times a negative 3x, that actually becomes a plus 6x. And then I have a negative 2 times a 3, and that becomes a minus 6. And that should equal a negative 3. Okay? So that was number 2. So this was number 1. Right there. This was number 2. Okay? And now it says solve for the remaining variable. So I'm going to solve for x. So this is number 3. So I'll combine my x's. So this is 9x here. I'm going to add this 6 to the other side. And I'm going to get a positive 3. So everyone see how I did that? And then I'm going to divide by 9. And I'm solving for x. So x actually becomes 1/3. Okay?
So does the negative 6 have to go to the other side?
It does. So I did a plus 6 here and I did a plus 6 here.
Oh.
And that became a positive 3.
Okay.
Okay? Questions so far? Alright, so now that I have what x is, all I gotta do is take that one and now plug it in and solve for y. So because I have this x equals 1/3, I'm going to put it into this equation up here. I'm going to substitute it in. So number 4. So this is number 4. I'm going to substitute this value into either equation. Doesn't matter which one I'm going to do. I like that it's a third and these are all 3, so I'm actually going to put it into there. Okay. So I'm going to say y equals, and I'll do -3 times 1/3. So now I'm just plugging in this value where I see x plus 3. So I get y equals -1 plus 3. So y equals 2. Okay? So in doing this was number 4. In doing this, I found a value for x and I found a value for y, didn't I?
Yes.
And that then would be the intersection point of those two equations. So if I actually took those equations and graphed them, they would actually intersect at -1/3, 2. Okay? So then number 5 says state the final answer. So you do it in an ordered pair. So my final answer would be 1/3, 2. Okay? If, however, we're going to see other examples, this is if it's just one, this is if it's a one-point solution. You would just do as an ordered pair. We have the 2 altogether, 3 altogether here, and we'll go through each one of those examples in just a sec. Okay? So, kind of just reiterate, and I'm going to have you try number 2 on your own. You have your 2 equations. In one of those equations, you want to solve for one of the variables. So you just want to have a variable on the left side equals something else on the right. Everything else is on the right. Then whatever that variable is, when you see it on the second equation, you want to substitute this value in there. So then you kind of eliminate, you're kind of getting rid of that y now, aren't you? Because you're saying y equals that. So this is the same value as this. That's why you can substitute this into that y, because they're the same thing. Right? So you do that, and now you're just left with the one variable. You can solve for it to get a number. Once you have a number, you can actually take that number and plug it in for it, and actually find out what y is, or the other variable is. Okay? Does that make sense? Alright, so let's do this. Why don't you guys go ahead and try number 2 on your own. Okay? Number 1, okay, solve one equation for one variable. Is there one of these equations that looks better than the other?
The bottom one solved for x.
Yeah, the bottom one looks better. So go ahead and try that on your own. In looking at number 1 on your sheet here, it says solve one equation for one variable. Look for the coefficient of 1. So that just makes it a lot easier to solve. So I'm going to look at this one here and realize that the x plus 4y is really the easiest one to make. So I'm actually going to change this to x equals -4y minus 6. Okay? No matter what you choose, you should get the exact same answer. However, if you can eliminate a bunch of fractions, I just think that's better. Okay? So at this point then, I'm going to look to the top equation here, because since I converted this one, I take this one and put it into the other equation. Okay? You don't want to take it back into itself, because that's defeating the whole purpose. You got to take this and put it into the other equation. You're substituting it in. So I know x equals this value here. So that's number 1 here. Then number 2 is going to be substituting it in. So I'm going to take this wherever I see x. So on my 3x minus 2y, where I see x, I'm going to plug this in here. So that's going to be 3. That'll be -4y minus 6 minus 2y equals 10. Okay, because that x, because that equals this, I can take this and plug it in there. Then I do my distributive property, so that's going to be a -12y. 3 times the -6 is -18. Minus 2y equals 10. So I'm just doing the distributive property to those. And now I'm going to solve for y. So I'm going to get a -14y. Is that what I get? And then I get a -18 equals 10. So I'm going to add 18 to the other side. So I get -14y equals 28. And then if I divide by -14, I'm going to get y equals -2. Okay? Now that I know that y is -2, I'm going to take this value and plug it into either equation. Okay? Because if I plug it into here, I'll get what x is. I'm just going to do that. So I'm going to take this value here, and I'm just going to plug it into this one here. So I'm going to get, so this was number 3. Number 4 is going to be substituted in. So I'll do x equals -4, -2, minus 6. So x equals positive 8 minus 6, because the -4 times the -2 is positive, and that therefore equals 2. So my ordered pair becomes 2, -2. If you went and did the opposite way, where you solve for y equals and then did a substitution that way, you should have gotten the exact same numbers. Okay? It's just you're dealing with fractions and it's not as pretty. Okay? So questions on that? Okay? So that's the substitution method. Alright? So now we're going to look at the next method, which is the elimination method. Okay? The elimination method is, I kind of have it on 2 sheets here. You have what to do on this side, but then you have the problems on the back side here. So, I'll try and do this for you guys so you can see it. Okay? The elimination method is kind of like trying to subtract out a variable. And you eliminate one of them by trying to create opposites. And this will make sense in just a second. Okay? So the first thing you want to do is actually pick a variable to eliminate. So again, you want to see what the easiest one is to eliminate. Eliminating means like an opposite. So if I have a 3x, I'd want to have a negative 3x as my opposite. If I have a y, I'd want a negative y to have as my opposite. Okay? Because then what we're going to do is by eliminating it, by having it be the opposite, it goes away when we add them together. Because they're the same at the same point, we can do this. Okay? So if I look at 2x plus 3y and I have an x minus 3y, is there a possibility of eliminating either one of those?
Yes, the 3s.
The 3s.
3 y's.
It's just by the fact of looking at them, you can see they're the opposite. So if they're the opposite automatically, you don't have to do anything. Okay? If they're not the opposite, you need to multiply the equations by a number that will allow them to be the opposite. And you'll see how this works in just a second. Okay? So the goal is to create, you can see here, opposite terms for your variable. Okay? You may have to only change the bottom one or the top one, or you may have to change both. So an example would be, like on 4, there's not a pretty opposite here. So if I chose, let's say, 15 to be my opposite, I'd have to multiply this whole thing by 5, and I'd have to multiply the whole thing by 3, and that would create the opposite. Okay? So we'll walk through this just a sec. Okay? But because we actually have an opposite already there, it's easy for us, and we don't have to do too much. Okay? So we need to add the 2 equations. So basically, by drawing a line and adding them, okay, this allows us to drop one of the variables if we create an opposite. Okay? Because we already have the 3y and a negative 3y, when we add them, those will cancel out. So the goal is to create it so that when I add these 2 lines together, 2 equations together, one term will cancel out. Okay? So if I add these together, a 2x and an x equals what?
3x.
3x. Okay? If I add a 3y and a negative 3y, what do I get?
0.
0. So those just cancel. And then I get an equals. If I add 2 and a negative 17, what do I get?
Negative 15.
Negative 15. Okay? So number 1 is to try to pick a variable to eliminate. So I made that the y. Number 2 was to create the opposite terms. It was already done for me. Okay? So I didn't need to do anything on number 2. Number 3 is to add the 2 equations together. Okay? So I'll put on already there. Okay? Alright, so then I add them together. Okay? One of the variables should be eliminated. Did we eliminate one of them?
Yes.
Alright, so we're good. We get to move on. Alright, so number 4 is now we get to solve for the remaining variables. Okay, so solve for x. So what does x become? Negative 5. Okay? And now that I have what x is, I can just plug it into an equation. You want to plug it into the top 2, not what you eliminated, right? You want to plug it into the 1 and the 2 and solve for the other variable now. Okay? So you substitute into either one of them. So number 5. I'll substitute into I'll do the top one here, or the bottom one here. So I'll do negative 5 minus 3y equals negative 17. Okay, so I'm substituting into this one. And then I do negative 3y equals negative 12. And then y equals 4. Okay, and so now I have an x and I have a y. So now I can write my solution as an ordered pair, and that's number 6. Okay. Okay. So in elimination, you want to try to create that opposite, and then you want to solve for the one variable because the other one should cancel, and then you take that value and plug it in. Okay. Does that make sense? All right. Yeah.
How did you get
How did I get y? Number 4 is not as pretty in regards to finding an opposite term. So you can make the decision. If I look at 5x plus 3y and 4x plus 5y, and I need to have one of those be eliminated, I have to find a number that they both can go into and multiply the whole top and bottom by that number to make it that same. So I could look at 5 and 4 and say, what's the number 5 and 4 go into? 20. I could look at 3 and 5 and say 15. So which one do you guys like better, 20 or 15? 15? Okay, we're going to do 15. All right, so we want to make these opposite, okay? So I'll multiply the top by 5. So I'm just going to multiply the top by 5. Okay? What would I need to multiply the bottom by to make the y an opposite of the top y? A negative 3. So I'll multiply the bottom by a negative 3. Okay? So therefore, the top one becomes 25x plus 15y equals 0. Right? Because then you distribute it to each term. And then the bottom becomes negative 12x minus 15y minus 39. And then I'm just going to rewrite this out so it is more aligned. Okay, so you guys got what I did? Okay, so now what's my next step? Add them together. So 25 plus a negative 12 becomes, any takers? 13x. Okay, these cancel, and I'm left with a negative 39. Okay, so now I divide by 13, x equals then a negative 3. So now what I do is my negative 3. Plug it in. Does it matter which one I plug it into? No, I can pick either one. So plug it into the original one. Don't go into the ones you actually modified. Go into the original one. So I would do, let's do 5x, 5 negative 3 plus 3y equals 0. So negative 15 plus 3y equals 0. 3y equals 15. Y equals 5. So then my order pair would be negative 3, comma 5.
Negative 3.
So it's always the x first and then the y on your answers.
I got 3, negative 5.
When you multiply the 13 by negative 3, you should have gotten negative 39. And then you'll have a positive 13. You divide it, you should have a negative 3. Okay?
And how to do the positive? So I would say that we try to get rid of, you could either multiply the top by 3, no, bottom by 3, and get
Okay.
6y.
Okay.
Is there any way you could get
Let's
rid of
do
that?
that. Let's multiply the bottom by a negative 3. Multiply the bottom by a negative 3. Okay? When I do that, I'm going to get, these 3's will cancel, and I'll just get 2x plus 6y on top equals 16. On the bottom, I'll get negative 2x minus 6y equals negative 54. Okay? Does that make sense how I got that?
Yes.
Okay? So when I do that and I add the two together, does anyone notice anything funky?
The X and the Y's both cancel.
Yeah, the X and the Y's cancel because I have a 2 and a negative 2, that becomes 0x, and I have a 6 and a negative 6, that becomes 0x, or 0y, and then that equals whatever this equals here, which is negative 38. So what's funky about that is I don't have a variable to solve for anymore, do I?
No.
Okay, so this becomes 0 equals a negative 38. Okay, is that possible?
No.
No, it is not. So remember how we have three conditions? It's 1 point, it's no solution, or it's all or infinite solutions? Which one of those three do you think this falls under? No solution. So what does that tell you about the two lines?
They never cross.
They never cross because they are parallel. Okay? So you can have it where they actually cancel out, and then that would be your answer on that one. Okay? Alright, so now, questions on that? Alright, let's look at number 6.
If you did a different number and found a different variable to do it somehow, it's still...
So in looking at number 6, can you guys just look at it and tell me if you can find a good cancellation?
The bottom one could be a mixed number.
You want to try and get rid of the fractions. Do something to try and get rid of the fractions. See if you can look at that and see what you got. Okay? So when I do that, notice how my x's cancel, so I 0x. I got my y's cancel, I got 0y. What do you notice on the right-hand side? That also cancels to 0. So this is a little bit different because now I got 0 equals 0. Does 0 equal 0, is that a true statement? It is a true statement. Therefore, because it is true, it is a solution, but it's a special solution. So of the three that we have, which solution do you think this one is? Infinite. Not all real, because I mean everything on the graph, but all that are on that line. So it's close. Infinite solutions. So then, what does that tell you about the two lines? What does it tell you about the two lines? They're the same line. They are the same line. So the lines coincide, as they say. Okay? And then what that ends up becoming is if you actually solve for y, you actually have it where they're both going to be y equals 3/4 x minus 3. So they actually would have the same y-intercept. Okay?
They have the same slope.
We've had two different ways of actually taking two solutions and solving them algebraically. We could have taken these and graphed it, and when we graphed it, you would actually see this is where they intersected. This would be their point, their solution. You could also solve for it, which is what we did algebraically. We did two ways of solving. We did substitution, where you solve for one variable, take that value and plug it into the other one, work your way through to solve it, and then plug that value into it. Okay? Or we had elimination, which is where you have to find a way of eliminating one of the variables by making it the opposite, the same opposite, and then solving for that variable, plugging that value into one of the equations, and then actually solving it that way. So that's the elimination. Okay, so those are the two ways that we learned. If you get a point, that is the solution. If you get it where it's like 0 equals a number, that is a no solution, meaning the lines are parallel. And if you get it where it's 0 equals 0, it's a true statement, and that's where you have infinite solutions and the lines coincide, meaning they have the exact same y equals mx plus b. Okay, so when we look at the story problem, it says, you are selling tickets to a high school play. Students' tickets cost $5 and general admission tickets cost $8. Okay? So I am reading this and I see two things. I see a student ticket price and I see a general admission price. Okay, I see two different things. Do you guys see that? Alright. One of those is probably going to be variable 1 and the other one's probably going to be variable 2. Okay, so we can assign student tickets as, let's say, x. Okay, and as I read, sometimes I just do this, and then sometimes I do that, so I tell myself they're two different things. So I'll say y equals general admission. I'll just say GA tickets. Okay? Alright, now we know that student tickets cost $5 and general admission costs $8. Now it says you sell 556 tickets and collect $3,797. Okay? So I know that my price of one student ticket is how much?
Is $5.
Okay. So I know that each ticket is $5 per student. I also know that the general admission is how much?
$8.
$8 per general admission. I have prices associated with these variables, right? If you notice, I have two values here. I have a $556 and I have a $3,797. Which one of those numbers, because you have an equal, right? You're going to have two variables equal something. Which one of those has to do with money? The $3,797. Basically what I just said is this amount of tickets at $5 plus this amount of tickets at that dollars is going to equal this total price that I have right here, when I actually brought money in, right? But then I have this other number. You sell so many tickets. Well, I know that's an equal. I know I have an equal 556. Okay? Well, what equals 556? All the
number of tickets.
Yeah, all the tickets I sold that are students,
That's why.
and all the tickets I sold that were general admission. So all my X's and all my Y's equal 556. Does that make sense? Okay. Do I have two equations?
Yes.
Okay. Now, I have two equations. Can I do substitution with one of them? Can I do elimination with one of them? Okay? You can. You have to decide which one you like better. So, I have single coefficients here, so I think I'll do the substitution method. That's just what I like. Or I could multiply the bottom by like a -5 and then eliminate. Either way. So you can take these and you can do one or the other. Which ones do you guys like better? Substitution or elimination? Elimination? Okay, we'll do elimination. So let's multiply the bottom here by -5. Does that sound good? Alright, so I'm going to get -5x minus 5y equals did I do that right? 2780? Anyone want to check my math?
2780.
Okay. So now I will add them up. So these cancel. I get 8y minus 5y, which is 3y, and that equals 3797 plus 2780. Negative, actually it's minus. This is minus. So 3797 minus 2780 equals 1017. So y equals 339. So I sold 339 general admission tickets. Okay? So now I can find out how many student tickets I sold. I'll plug it into this bottom one here. So I'll do x equals x plus 339 equals 556. Okay? So 556 minus 339 equals 217. So I sold 217 student tickets.
Could it be different, like maybe the math can add up any other way and you have more or less, or